Okay, including tables in this unit is helpful for understanding function compositions and function inverses in a different way. So, if as an introduction, let's say I want us to find G inverse of negative, let's do positive 8, G inverse of 8. Okay, we need to remember that inverses take outputs and they send them back to inputs. So these are all the outputs of G. These are all the outputs of F. These are the inputs. So if I say G inverse of positive 8, what it's saying is I'm going to go to the output 8 and I'm going to see what input it is. So it's 5. So G inverse of 8 is 5 because G of 5 is 8. G inverse of 8 is 5. So these types of problems cause you to think on a couple different levels because it'll do inverses and it will also do function compositions. So when you really understand this type of problem, you can almost make the problems yourself just from looking at a table. So for example, I'm going to look and I'm going to see if there's a way I can compose f and g either through inverses or not so that I can end up with an answer that will be able to be found from this table. So for example, I'm looking and I'm saying, well, if I were to send the input 2 to the output negative 6, I'm also noticing that f also has an output of negative 6 that would get sent back to an input of negative 3. So what I can do is I could say g of 2. Let's say g of 2. Okay, again, we know that g of 2 is going to be negative 6. So then if I throw an f inverse on the outside of this, then I should end up with an answer from the table. So let's do it again. So we have g of 2. G of 2 gets sent to the output negative 6, so that's what we're going to plug in at f inverse. So showing our steps here, we have f inverse and of negative 6. Okay, so now for this, we're going to go to the outputs of f because it's the inverse function, negative 6, and we're going to see what input goes with that, and it's negative 3. So our final answer then is negative 3. F inverse of g of 2 equals negative 3. By following this path, we can see why that's true. So let's see if we can come up with another one. Okay, so I'm seeing 8 show up a couple times. It's the output of g for 5, and it's also an input that could lead to an output for f. So what we could say is, we could say g of 5. We know that's going to be 8, so then if we say f of g of 5, then that will lead to an answer. So let's follow our path again. So we said that g of 5 is going to lead to an output of 8. So this gives us f of 8. That's what's going to get plugged into f. And again, because it's f this time, 8 is an input. So let's follow our path. We say f of 8. What is f of 8? It's equal to 2. So our final answer is 2. So the trickiest these problems will get is throwing some operations inside our parentheses as well. So by way of example here, if we plug in 5 to g, we get 8, right? So we say g of 5 is 8. But let's say I want to end up doing f inverse of 9. I don't want to do f inverse of 8, I want to do f inverse of 9. So what we can do is we can say g of 5 plus 1. Okay, we know that's going to lead to a result of 9. So then if I say f inverse of g of 5 plus 1, let's see what that gives us. So we know that g of 5, because we just constructed this problem, g of 5 is going to be 8. So now what do we have? We have f inverse of 8 plus 1. Well, that's just f inverse of 9, right? F inverse of 9. So then we're going to see what f inverse of 9 is. So we go to the outputs because it's f inverse. Inverses send outputs back to inputs. F inverse of 9 is going to be 11. So our final answer is 11. So really being careful with our steps and using the table, drawing some lines really helps us keep these types of problems straight for sure.